Hello friends, welcome to Dr. Sai Physiology Academy, DOPA for short. This is the place where we make the learning of physiology easy, exciting, and effective. Thank you for joining me. And if you're new to this channel, you're especially welcome. And if you love the content that we share, kindly click the like button and also the subscribe button. And don't forget to turn on notifications so you don't get to miss any new content that we drop. Now let's get started. So we are entering the female reproductive system now. And we don't want to waste too much time talking about functional anatomy of the ovaries and all of that, attachment, connection with the fallopian tube. It's easy, it's in the books. Let's just go straight to the most difficult part. It's understanding this menstrual cycle, because it's not very straightforward. Okay, it's very technical. In fact, not everything has been understood about the menstrual cycle. Okay, that's why we're going straight into it and pay very close attention. Now, the menstrual cycle, anything that has to do with cycle, is talking about changes that occur in a repeatable and predictable manner, in the sense that the end is linked to the beginning. So as the end is happening, it is leading to the beginning, and it continues to go like that in a predictable, repeatable manner. That's a cycle. And the changes we are talking about here has to do with what happens in the ovaries. Okay? That's why the menstrual cycle is divided into two, because whatever is happening in the ovaries is reflected in different sexual organs, but mostly the uterus, because it's the uterus that manifests itself out as menstruation. So that's why we now divide it into both ovarian cycle. The menstrual cycle is divided into ovarian cycle and the uterine, as from the uterus cycle. This can also be called endometrial cycle, because one of the layers, the superficial layer of the uterus, is called endometrium. Okay, so it's also known as endometrial cycle. Okay, so they're not different. It's just a mirror of what is happening here. So whatever is happening at the ovaries is being reflected. The changes happening here is being reflected by changes that are also happening here. So we're going to divide into two parts. In this part one, we're going to talk about the ovarian cycle, and in part two, we'll talk about the uterine cycle. Is that okay? Now let's get started in the real sense of it. Now, understand it. I'm going to make it easy for you. There are two types of hormones that you need to understand how they play. In fact, 4 hormones, 2 from the pituitary hormones, and the ovarian hormones. Okay, we're going to be looking at these 2 types of hormones and what they do. Now, the pituitary hormones we're talking about FSH and LH. From the introduction, you already know follicle stimulating luteinizing hormone from the gonadotropes. Okay, then the ovarian hormones we are referring to here, estrogen and progesterone. So a simple way to understand this thing is that now the FSH, the ovarian cycle, is divided mainly into 2 stages or 2 phases, although in the books is referred to as 3 phases or 3 stages. Okay, the middle stage is the ovulation. Okay, ovulation is just an event, so it's what separates the 2. So understand it from this angle. There are 2 major phases. Okay, so the first part, the first phase, is mainly controlled by the FSH. Understand it like this: the ovarian cycle. So this the first part or the first phase, why the luteinizing hormone dominates the second phase. Then when you come to the ovarian hormones, estrogen dominates the first phase, while progesterone dominates the second phase of the ovarian cycle. All right, so now we're going to mention the phases and what these hormones do. All right, now the beginning of the menstrual cycle. Okay, menstruation marks the beginning. We're going to talk about in the uterine cycle, but that's what marks the day one of the beginning. You know, it varies in different women, but the average is 28 days divided 14. But the second phase is usually constant. So if there's a variation, that means the variation is in the first phase. So what is that first phase? Ovarian cycle. It's called the follicular phase. Follicular phase. Second phase is known as the luteal phase. Luteal phase. Okay. Now, so what happens in the follicular phase? Now look at it. FSH, follicle stimulating hormone, dominates. Okay. So what happens is that, you know, we have follicles surrounding the oocyte. Remember, you have an oocyte like this with nucleus. Then you now have smaller cells in layers. Okay, we talked about that earlier, the structure of the gametes. Look for the video and watch. So the one closer to the oocyte, they're known as granulosa cells, smaller than the one outside, they're known as thicker cells. Okay, but all of them are known as follicular cells. So what happens is that in the early part of the cycle, FSH begins to be released more than LH. LH is released, but FSH is more dominant in that first part. Okay, so FSH begins to stimulate these follicles to begin to grow and multiply. That's what it does. Multiplication and growth. It begins to divide, increase, and the layers begin to increase and so on. So it recruits different follicles. So not just only one, like hundreds are growing and multiplying at the same time. So that's what it does. FSH. Then also something happens. The little LH that is being released, we've talked about it before, it acts on the thicker cells of those multiplying follicles, the thicker cells, okay, because they are the ones that have LH receptors. So the LH acts on the thicker cells to produce androgens, more specifically androstenedione. Androstenedione. Okay, so it produces androstenedione. Then this FSH that causes stimulation, growth, and all that has another effect, but this one is specific to the granulosa cells. So the effect there is to make the granulosa cells to secrete aromatase that now converts androstenedione into estradiol. Okay, but estradiol is the most abundant estrogen. So it converts this androstenedione produced by the thicker cells into estrogen. So look at it, estrogen abundant dominates the first phase. So this is how it happens. So don't get confused about it. FSH, multiplication of the follicles, then LH causes the thicker cells, which is part of the follicles, to secrete this. Then the same FSH acts on the granulosa cells to release aromatase that converts this to estrogen. So estrogen is now being secreted in larger and larger quantities. So this is where it gets interesting. It now begins to have a negative feedback effect on FSH. Do you understand that? That means it now begins to reduce FSH. But look at what happens. Because there is only one oocyte that is released usually from one ovary per month. But hundreds were recruited by FSH. So that is there's going to be a selection of a dominant. So it happens that the follicle that is the largest, that is bigger than the rest, that has more FSH receptor, will not be affected by the reduced FSH. Are you getting it? The estrogen secreted by all of them causes a negative feedback effect on FSH. So FSH is now reduced. So that means it doesn't stimulate them anymore. So the smaller ones are going to die off. But the biggest follicle, which is now known as the dominant follicle, has so many FSH receptors that they are not affected. They continue to secrete estrogen. Okay? So the thing is that very, very important and tricky, high levels of estrogen, okay, has a negative feedback effect on FSH, reduces it. But when that one dominant follicle is selected, it continues to secrete more and more estrogen. Then you now have something interesting. Very high levels of estrogen now has a positive feedback effect on FSH. So FSH went down and now it now comes up again because increasing this thing, secretion. So FSH is now estrogen now has a positive feedback on FSH. So FSH now continues to be secreted more. So the major aim at the first part is to develop so many follicles and select a dominant follicle. That's the purpose of the FSH on the granules, on the follicles at the initial part of the cycle. So once that is selected, the effect of estrogen on FSH now becomes a positive feedback effect. So what happens is that very high levels of FSH, because it's positive feedback, so very high levels of FSH has a different effect on granulosa cells. The first part, the effect was to produce aromatase. Now and then when the selection has happened, the effect now, very high levels, is no longer aromatase. So the effect now is to cause what is known as luteinization of granulosa cells. So very high FSH causes what is known as luteinization of granulosa cells. What do we mean by luteinization of the granulosa cells? It means that it causes the granulosa cells to start expressing LH receptors. Initially, it was only the thicker cells that have LH receptors, which the effect is to produce androstenedione. But now, the granulosa cells now have LH receptors because of high levels of FSH. So what happens now? Listen very carefully. They now have LH receptors. So LH, which has continued to be secreted, now the effect of LH on granulosa cells is now to do what? To produce progesterone. The effect of LH on thicker cells was to produce androstenedione. Now the effect of LH on granulosa cells is to produce progesterone. Okay? So progesterone itself has a positive feedback effect on LH. Okay? Positive on LH. So this is where LH now begins to rise. FSH has done its own work, the high levels for luteinization. Then progesterone has positive feedback on LH. So more progesterone is produced, more LH, which acts on more of the granulosa cells, which already have LH receptor, or produce more progesterone and so on. So it now happens that you now have what is known as the LH surge. Positive feedback. So this LH surge happens about 36 hours before ovulation. LH surge, 36 hours before ovulation. Okay, so how it causes ovulation, it's a very complex mechanism, but the simple gist there is that it helps to recruit macrophages that now go to that oocyte, the follicle, and they begin to secrete substance, the prostaglandins and all of that, okay, that now digests the follicle surrounding the oocyte. So the oocyte is now released from the follicle into the abdominal cavity, which is known as ovulation. Okay, the oocyte, you know, the oocyte is the big one here, surrounded by all those follicles. So only the oocyte is released, right, leaving the follicles behind, which will now bring us to the next phase, the luteal phase. So I'm going to be dissecting the luteal phase after this break. All right, you're welcome back. So briefly, let's just talk about the luteal phase, which is the later part of the ovarian cycle. So it's very easy to understand. The moment ovulation happens, the luteal phase begins. So what happens that the oocyte has been released, leaves behind all these granulosa cells there. So those granulosa cells is now known as the corpus luteum. Corpus luteum. Okay? Luteum, why it's called that is because they contain a yellow pigment known as lutein. Lutein. Okay? Corpus, body. The body that contains yellow pigment. So that's what happens. So what happens is that they continue to secrete progesterone, but in addition, they now begin to secrete inhibin. Okay? So the corpus luteum secretes progesterone, let's just write it prog, and plus inhibin. So this progesterone and inhibin in that luteal phase inhibits secretion of FSH and LH from the anterior pituitary, so that they don't stimulate more follicles to develop. You know, this one, they can stimulate follicles to develop. So it inhibits these two, all right, so that only one follicle will go ahead. So what happens is that after several days, if fertilization does not occur, this corpus luteum will die off. And once it dies off, the progesterone inhibitor that was secreting, that was inhibiting these two things, is no longer there. So the anterior pituitary is released from that inhibitory effect, and then they start secreting FSH and LH, which will now be happening in the next cycle. Do you understand? But if fertilization occurs, as the developing human, the embryo develops, there are some cells known as trophoblastic cells that begin to secrete HCG, human chorionic gonadotrophin. So this HCG, what it does is that it prevents the dying of the corpus luteum. Do you understand? The corpus luteum remains alive to continue to secrete progesterone and inhibin and so on and so forth, which now continues to maintain pregnancy. progesterone is known as the hormone of pregnancy. So this brings us to the end of the ovarian cycle. So in the part 2, we're going to be talking about the uterine cycle. What is happening in the uterus as all these things are happening in the ovaries. Okay, so just meditate on it, play it over and over again, so that it sinks down. The different high estrogen, very high. What happens? High FSH, very high, causes luteinization, and all of that. Very simple, so you digest it. All right, so I'm going to see you in the next video.